Welcome to today's webinar on Out of the Fire, adding layers of protection when deploying Oracle eBusiness Suite to the Internet. My name is Phil Ryman. I'm the Director of Business Development at Integrigy, and I'll be the moderator for this e-learning session. The speaker today is Stephen Coast. Steve is the Chief Technology Officer and founder of Integrigy Corporation, and he's been working with the Oracle products now since 1994 with responsibilities that include database administrator, technical architect, IT security auditor, and applications administrator. For the past 12 years, Steve has focused on the security and auditing aspects of the Oracle Business Suite and the Oracle database, and has written and presented on these topics at various national and regional conferences, including OAUG and IOUG and the National Collaborative Conference. In fact, if you're going to the Collaborative 12 in Las Vegas next month, be sure to stop by and see one of Steve's 4 sessions he's getting, both for the IOUG and the AOUG. So now I'll turn it over to Steve.
Thanks so much, Phil. So welcome, everyone. And what today's presentation is a continuation of one we gave a few weeks ago called Into the Fire, which describes some of the security risks and issues with deploying the Oracle eBusiness Suite on the Internet. So what we're going to talk about today is a continuation of that discussion and talk about what are some of the other things that you can do to protect the Oracle eBusiness Suite when you deploy it to the Internet. So we'll talk about it first. We'll give a little recap about some of the Oracle eBusiness Suite web security issues, kind of talk about web security in general also. And then we'll talk about 3 main topics. One is unpatched security vulnerabilities. So a lot of organizations can apply security patches immediately, so Oracle releases them on a quarterly basis, and the question is how quickly can you get those patches, and we'll talk about that. The second area is unknown vulnerabilities. So when you've got security vulnerabilities that are unpatched but actually aren't even published by Oracle yet, how do you proactively protect in case there's something there that someone else can find? How do you provide a layer of protection for that? And then we'll finish up with talking a little bit about encryption, and hopefully everyone will understand about how vulnerable the Oracle eBusiness Suite is when you're sending sensitive data, passwords, and things across the Internet. So before we get started, a brief overview of Integrigy. For those of you not familiar with us, we're basically a very specialized consulting and software firm specializing in Oracle eBusiness Suite and database security, specifically Oracle and Microsoft SQL Server. And we've actually got 2 separate sets of products and services. On the product side, we've got actually AppSentry, which helps automate the auditing of an Oracle eBusiness Suite environment. So we'll actually check that all the security settings are done appropriately. And we also have a product called AppDefend, which is basically an application firewall for the eBusiness Suite. It's very specialized, and we'll kind of briefly touch on that during this presentation. And then on the services side, we actually do security assessments, compliance assessments for customers who are trying to work with SOX, PCI, HIPAA. And we also do security design services. So if you do have issues regarding auditing, encryption, how to deploy and do your DMZ architecture, we can actually assist you with that. One of the questions we do get quite often is, how does Integrigy know so much about the Oracle eBusiness Suite? Well, that's one of the things that we focus in on. We found a number of Oracle security bugs over time. So we've actually found over 70 security bugs in the Oracle eBusiness Suite. So we very much proactively research, work on discovering issues, how to best protect it, some of the things that are above and beyond what Oracle's best practices are. So let's start talking about Oracle eBusiness Suite web security. And what I'll do is kind of step back and talk about security at a high level in the application, then talk about some of the specific security risks. So this diagram shows the classic Oracle eBusiness Suite DMZ architecture. So what you're trying to do is provide a multi-layered approach, trying to protect with different layers of protection, starting with encryption at the first level, a reverse proxy hopefully to at least shield the your external application service from the Internet, and then providing firewalls in between each layer to only allow access to certain web ports, specifically here for 3, which is the SSL port, maybe port 80, and not actually allowing direct access from the Internet to your database ports or your eBusiness Suite ports. So trying to provide at least some level of filtering, some level of blocking access directly to the different components within the eBusiness Suite. And what we'll do is kind of take this architecture and dive into it a little bit more and try to describe on how some of these layers can be enhanced throughout this presentation. So let's first talk about the Oracle Web Footprint. So when you install Oracle Release 12, and this also includes 11i, you get a fairly large install. The application is very well integrated, so all modules really interact together, are one big package. Because of that, when you actually install the Oracle E-Business Suite onto an application server, you're actually getting the entire install. So if you're running Oracle Financials, well, you're not really running Oracle Financials, you're running Oracle Financials, CRM, Manufacturing, HR, Oracle Student System, and a whole bunch of other modules. The application is so tightly integrated. When you go through the install process, there's no point there that says, oh, just install Oracle Financials. We're just running GL, AP, fixed assets. No, there's no way to do that. You install everything because all the code is so dependent on each other and highly integrated. The easiest way to do it is install the entire application. And this works for 11i and R12, and there's no way you can change this. So when you're installing it, you're getting 20, 30,000 web pages actually installed. And if you don't go through the DMZ configuration very closely, this is all there. So if you just deploy your internal application server on the internet, you're deploying Oracle Student System. Even though you haven't configured it, licensed it, or done anything else to it, it's still available. Those web pages are there. And so if there's security vulnerabilities that happen to be in it, such as the Oracle Student System, I'm just picking on that, but it could be any module, those are exploitable. And often a security vulnerability is within the code fairly early on. So even if you haven't configured it, when you try to access a student system web page, it probably will blow up at some point because it says it's not configured. But more often than not, you can actually exploit that security vulnerability even though that module is not installed or configured because the web pages exist. All the code is there and you can execute it. And then the second major issue with the Oracle E-Business Suite, and this is just the way web applications work often, is whenever you access the database, all access from the application server is using a single account, the apps account. The apps account in the database owns the data. It owns the application. So anytime I can compromise the application server, I have full access to the database. So even though I may not be running Oracle HR on the internet, if there is a compromise within the application, maybe a SQL injection bug, or I can do something else to the application, I can potentially access any data, including HR data. So the scenario is, if there's a security vulnerability within iSupplier, and let's say it's a SQL injection, which allows me to potentially execute queries against the backend database, I could potentially bring back all your HR data. That's very powerful, and that's why spending some time in securing the application correctly is very important, because a compromise can be very intrusive, can actually access all data, can compromise the entire database. I'm not just compromising iSupplier if I'm implementing iSupplier on the internet. I'm potentially compromising the entire application. So what do we do to protect it? Well, Oracle has come up with a very detailed set of configuration standards and steps. So Oracle's gone through each module and said, for Oracle E-Business Suite R12 and 11i, here's the list of modules that are available, and here's the specific steps that you actually have to follow. So here's the two, my Oracle support notes. I almost said MetaLink, but basically whenever I say MetaLink notes or my Oracle support, those are the same thing. And so you have to actually take each of these documents and go through them for your version and specifically configure the application step by step in order to secure it. And there's a number of issues because, remember, this is a fairly old application. It was developed in the late 80s, and Oracle kind of moved it to the internet. And so there's a lot of legacy pieces to it. It started off as 10.7 Smart Client, and then all of a sudden went to the web very quickly. And the way they transitioned to the web was through a few different web architectures, ModPL SQL, then there was JSP pages, and then there were some servlets, and now it's the OA framework. In 11i, all those web application frameworks still exist. So you have to be careful you don't expose something that's older in the application because it's still there. Oracle doesn't remove a lot of those pieces when they're actually installing it. So within 11i, even though ModPL SQL isn't used as much anymore, there's a lot of ModPL SQL pages still available. There's a table within the Oracle E-Business Suite, FND enabled PL SQL. There's 600 or 700 different pages within that list that basically allow someone on the web to directly access and execute a PL SQL package stored in the database, which generates a web page. So as part of this configuration, you're blocking access to a lot of these unused pieces. So basically, what the DMZ configuration documents are doing is basically limiting what can be accessed via the internet and trying to provide some level of security. And there's really two main components of that. The first is the URL firewall, which is a white list of all the pages that can be accessed. So let's say the application here in R12, it's around 25,000 different web pages. And what you're trying to do with the URL firewall is really cut back that number of web pages dramatically. And basically, if you're running iSupplier, there's only a few web pages that should be accessible. And primarily what those are the standard AOL or FND pages that'll let you sign in to the application, provide online help, those sort of common services. Then the key one is OA framework. So there's two really main OA framework pages, OA.JSP and RF.JSP. And if you ever run eBusiness Suite, just look in your browser, look at that URL window up at the top. That's basically http:/yourname/something, and just look at some of those web pages being accessed. What the URL firewall is saying is only certain of those web pages can be allowed. And then there's a second step. Because the OA framework is really just a couple web pages that are accessing multiple responsibilities, then you're actually setting the node trust level. And what the node trust level is doing is actually limiting the responsibilities that can be accessed externally. If you don't enable the node trust level, you can actually have someone with like system administrator access actually accessing the application remotely. They really shouldn't be doing that. They should be going through your VPN, connecting to your internal network, and then accessing sensitive functions. Because when you're deploying Oracle eBusiness Suite to the internet, there's only certain modules that are certified by Oracle to be deployed. These have additional security measures, have been through penetration testing by Oracle. So unless it's certified, it shouldn't be on the internet. And these two pieces, the URL firewall and the node trust level, actually work together to help limit access, reduce the surface area, eliminate non-external modules from being accessed. So it's very important that you go through the DMZ documents from Oracle very specifically and do all the configuration steps. And a key to note is the URL firewall is actually an appendice. It's not very clear in the document if it should be implemented. It's Appendix E in both documents, and it is a very mandatory step. So be sure when you're implementing it, you've enabled the URL firewall. And then also the URL firewall is actually enabled as part of autoconfig. So it's possible that you can actually edit the file, and if you're not doing it properly, you can actually overwrite next time you run autoconfig, and it'll actually replace the file and do some other things. So you always have to be careful about going through the DMZ steps and test it periodically to make sure both node trust level and URL firewall are enabled properly, because it's actually pretty easy to disable them by accident if you don't do the configuration correctly the first point, and then as soon as you run autoconfig, it gets reset. So that's kind of the basic pieces that Oracle provides as part of the DMZ security, which is pretty good. It's actually providing a much reduced surface area. You're taking 250 modules available on the internet without it, and hopefully reducing it down to just what you need. So now let's kind of take it from a different perspective. So what are the problems with web security? So if I have a web application, I'm deploying it to the internet, what are the things that I need to be thinking about? And fortunately, there's two very good organizations that are basically security professionals, users, large corporations that have gotten together and said, okay, we need to think about web application security and how we need to protect it. So the first one is OWASP, the Open Web Application Security Project. And OWASP is a very good organization, and they provide a lot of knowledge. And one of the things that they do every year is publish a top 10 list. So they've gone through and thought about web application security and said, what are the most common security risks to a web application? And let's rank them by level of risk. When we look at the different breaches out there, things that are happening out on the internet, companies losing data, how are they losing that data? How are they being compromised? And so they've gone through it, picked out 10 areas. And so now what I've done is taken those 10 areas and mapped it directly to the Oracle eBusiness Suite. Some of them aren't as critical for an Oracle eBusiness Suite implementation because these are generic web applications. So they may be using different frameworks like PHP or Java. Oracle eBusiness Suite's using Java. So the areas in red are really the highest risk for an Oracle eBusiness Suite environment. Green is the lowest risk. So the first one is injection. That's either SQL injection, HTML injection, XML injection. And basically what injection is I can actually take code and have it executed as part of the application. That shouldn't be there. And I'll talk more about SQL injection and cross-site scripting in a little bit. The second area is cross-site scripting, and I'll actually give you a fairly good example of how an Oracle E-Business Suite environment may be compromised using it. Other areas where Oracle E-Business Suite is actually fairly good is session management, authentication. They've done a very nice job on how they do authentication and session management. It's very difficult to circumvent it. So that's usually not a problem in an Oracle E-Business Suite environment. For some customizations, it's kind of one of the areas that we do see a problem there, but the core Oracle code is pretty good. Security misconfiguration is an area where Oracle E-Business Suite tends to have some problems because it is a manual configuration effort to implement the DMZ configuration. So unless you're doing your URL firewall correctly, it's a set of rewrite rules which are using regular expressions to work. We've seen a number of cases where people have changed the rules that had to add some customizations that actually allow way too much. So those are the type of things that are the main problems. And so this is kind of our foundation. So when we start talking about Oracle E-Business Suite security and deploying this web application to the internet, this is the type of areas we're looking at. We're using actually a fairly good foundation to talk about what are the issues and what are some of the security risks. A second organization is the Web Application Security Consortium. And again, another group of web application security experts have come together and said, okay, what are kind of all the threats to a web application? So this is a little bit different view than OWASP. And what they've come up with is a more detailed threat classification. So the Web Application Security Consortium came out and published what are the attacks and weaknesses. Let's come up with a whole glossary of all the different possibilities. And this list is always changing because there's always new things discovered. But basically they've gone through, and what I've now done is mapped all the threat classification categories to the Oracle E-Business Suite. So said, okay, what's high risk? So an example of high risk is abusive functionality. Are there things within the Oracle E-Business Suite functionality that potentially I can use, such as the examples of sending out emails within the application? So can I abuse that functionality to send out spam instead of sending out normal emails? Brute forcing, can I brute force application sign-ons and things, and will the application log me out? Fingerprinting, information disclosures are actually a big issue within the Oracle E-Business Suite. It's very easy to find out within the Oracle E-Business Suite exactly what version you're running, potentially patches, versions of the database, application server. That actually information is easy to get, which helps an attacker figure out within the application where you might be vulnerable, which then lets me direct my attacks and hopefully circumvent any security measures you have. So this is kind of our foundation, how we're thinking about the Oracle E-Business Suite. This is kind of more of a technical, detailed view, but we're actually going through each of these and saying, okay, where within the application is it vulnerable, and how can we protect it against these type of attacks? So that's kind of the foundation, a little bit of background. I just want to kind of level set everyone because I know some people weren't on our previous webinar. So now let's talk about a couple of areas where we can hopefully add additional layers of protection to the Oracle E-Business Suite and actually protect it more. And the first area is unpatched security vulnerabilities. So the fundamental definition of unpatched security vulnerability is that Oracle's released an Oracle Critical Patch Update, and so there's a fix out there. But unfortunately for your environment, you have to actually test that fix. You have to apply it to your development test environment and then eventually get it to production. And hopefully you don't have to do any application or database upgrades along the way, which would then further delay that. So there's a window of vulnerability between when Oracle releases it and when you actually have the patch. And if there's maybe a SQL injection bug in iSupplier, you have a fairly large window of vulnerability. And so I've talked about SQL injection already, so let's give you a little bit more of an example. This is actually a real security vulnerability. It was patched part of Oracle Security Alert number 32, which was back a number of years ago. So I'm just using it as an example. But this is actually, if you went back and probably found an 11.5.2 environment, fairly old, this would actually be vulnerable to it. So this is the URL. So if you just put this URL up in the browser, you would see it's actually pulling up the way they used to do help in older versions of 11i. And what it was vulnerable to was basically SQL injection. So the code in red there will actually be executed as part of a SQL statement, and this will actually get appended in. And this particular SQL injection vulnerability allowed me to execute any functions. And in this case, remember, all the code is running as apps in the background. So anything I can do is running as apps. And so all we did was find the function that we'd like to use, and in this case, it's the change password. And we just called, for the operations user as an example, I would just change the password to welcome1. So a very kind of powerful SQL injection bug that now I can kind of just, now I have full access to the operations user because I just changed the password. But those functions could be just about anything. But this is an example of how simple a SQL injection attack can be. They're difficult to find, but once you find one, it's a very powerful attack against the application because remember, everything's executing as apps. So in this case, sometimes they're executed as functions. Sometimes I can actually retrieve data. So there's been a number of cases where there's been SQL injection bugs in list of values. So not only can I bring back the standard list of values, I can actually append any data I want to that. So a classic one there was it would bring back a list of your suppliers. Instead, I just add a union statement and bring back a list of all your employees as part of the PR all people left table, which would include those security numbers and things. So it's actually pretty powerful on some of the things you can do with SQL injection. So a lot of times we get the question is, well, so how big of a deal is this? How many unpatched security vulnerabilities there are? Well, if we go back over the last 7 years and look at how many security vulnerabilities have been released in the Oracle E-Business Suite, there's been 232. So this isn't a minor problem. Everyone's like, oh, there's maybe 1 or 2. No, there's hundreds of security vulnerabilities that have been patched over time. So on your environment, how many quarters are you going back? And not all these are actually web application vulnerabilities. Sometimes they're in the reports, sometimes they're in the forms. So now if we break that number out a little bit, we've gone through and kind of estimated. We tried to count them up. You'd have to go through all 232 and count them up each quarter. And we've done that for a couple of quarters and extrapolated it out for the rest. But basically, out of those 232, about 60 were SQL injection in web pages, 70 are cross-site scripting, which is a little bit lower risk in the Oracle E-Business Suite, but still can be actually useful to do things. A number of them were actually in authorization and authentication. So that's basically issues with the sign-on pages and things like that. Those tend to be older bugs, where the cross-site scripting ones are the ones more commonly found today. And then there's been a number of business logic issues. And a business logic issue would be defined as I can circumvent something. One example is we found a fairly serious bug in the self-service registration pages that would actually allow someone to circumvent how you do self-registration for HR employee self-service. That would be an example of a business logic issue that I can kind of circumvent it by doing different things to that page. So these are real problems. These are real security vulnerabilities, and every quarter there's at least 1 or 2 that affect something to do with the web application security. So it's always a moving target. So every quarter that Oracle releases their critical patch update, there's always another security vulnerability you need to be thinking about. So hopefully everyone on the call is familiar with the Oracle critical patch updates. But one of the major issues is their cumulative patches. So when you're deploying iSupplier to the internet, it's a cumulative patch. So it may include fixes for a number of different modules, not only iSupplier. There's no way today just to say, well, there's a security vulnerability in iSupplier. I'm running iSupplier on the internet. That's where my risk is. Let's just apply the iSupplier piece to it. You'd have to reverse engineer the patch and pull out that specific change in order to get it versus applying the large cumulative patch. So the problem here is it's slowing you down in terms of having the CPU applied quickly, especially because your risk exposure is much greater externally than internally. Well, you might get hacked internally, but you're more likely, you've got 1 billion people on the internet attacking you externally. Internally, people would have to get past your first line of defense, be on your internal network, or be an internal employee to actually attack you. So we view the external risk much greater. So that's why you want to patch your iSupplier much quicker than you would maybe your internal application servers. And then to actually get the patches applied, you have sometimes upgrades. So if we're looking at the different versions, you may have to be on 12.1.3 of the application or 12.06. You might have to apply some ATG patches to actually get the patches applied, especially if you're behind on CPUs. There's dependencies. Sometimes when you go through the patch readmes, you actually have to patch more than one, you have to apply more than one patch. Then also there's dependencies. So a lot of times when you look at the patches, well, there's one vulnerable file, but it may update 10 AP forms versus just one, so there's actually additional testing required. And then, once you've kind of figured out all the upgrades and things, then you have to go through your standard testing cycle. Hopefully when you're applying critical patch updates, you are applying it to development, test, and then production to make sure that there's no bugs. So people aren't really applying these very often, not as quickly as they should be. In my opinion, it should be, for an external deployment, doing it within 1 to 2 weeks to eliminate the exposure, because that's where you're going to get attacked. The way around this is actually called virtual patching. So the assumption is you can't apply the patch immediately, as for all the different issues we just talked about. So there's really just several ways to eliminate the risk. You can write your own rules. So if you do have a web application firewall, or you could actually use Oracle's eBusiness Suite's implementation mod security. So Oracle eBusiness Suite comes with a web application firewall already installed called mod security. There's a few limited rules within that, but you can actually add your own rules if you want as part of the custom.com file. But the problem here is you have to figure out what the vulnerability is within the critical patch update and write your own rules to protect it. Or potentially you can also add it to the URL firewall and block the specific pages that are vulnerable. Another option is Integrigy actually has a web application firewall that we have specialized for the Oracle eBusiness Suite. And we actually analyze the critical patch updates, figure out where the vulnerabilities are, and actually include rules delivered with our updates that we do at least every quarter for AppDefend. So we're predefining the rules, so basically they're all ready to go for you. And if it's on a page you typically use, we actually get down to the parameter level and say, well, this parameter has a SQL injection bug, but you need to use the page, and therefore we can actually provide additional checking on that one parameter to make sure that there's no vulnerabilities within that parameter. And so these are kind of some of the options for virtual patching. Virtual patching has taken off in the last couple of years as a way to try to get off some of the critical patch update cycle. It is difficult to apply those patches, but you need to reduce the vulnerability, and virtual patching is actually a really good way to do that. So you're eliminating the vulnerability without actually having to apply the patch immediately. Applying patches introduces risk into your environment, so every organization is trying to reduce risk. Unfortunately, on the opposite side, you've got risk of being open and vulnerable to these security vulnerabilities. So that's a little bit about patched security vulnerability. So basically, when you have that window of opportunity for an attacker between the time the patch is released and the time you can apply the patch. So the flip side of this is, well, there's unknown vulnerabilities. Integrigy does research, so we have at least 5 or 6 open security vulnerabilities with Oracle right now that haven't been patched. Or people are finding them every day and sending them to Oracle, or kind of keeping them so they can use them. And it's actually somewhat easy to find Oracle eBusiness Suite environments on the internet. So if you just Google OA_HTML within Google, you can actually start finding people running iStore, iSupplier, and other sites on the internet. So it's actually fairly easy once you find an Oracle eBusiness Suite vulnerability to actually find possible targets. So how do you protect yourself against these unknown vulnerabilities? So there's several examples. We've talked about SQL injection, but there's also cross-site scripting and other issues within the application now that you have to protect against. Another example is indirect object references. We just did a security audit of a client last week, and we actually found an example of this, of basically being able to type in a URL and bypass security when we shouldn't have been able to. So there's lots of different security vulnerabilities within the application. So how do you protect yourself against these type of examples? And a classic one is cross-site scripting. For those of you not familiar with cross-site scripting, if you look at some of the recent hacks to Amazon, eBay, some of the large e-commerce sites in the last several years, this is how those companies are losing money. And so within the Oracle eBusiness Suite, it's not as common for a cross-site scripting attack. We kind of deem it as a low to medium risk, where we'd look at SQL injection as extremely high risk, high value, high risk. An attacker could really use SQL injection. Cross-site scripting is more of a specialized attack. It's more of a phishing attack. So if I knew you were running Oracle eBusiness Suite on the internet, I could possibly find out who's running the Oracle environment, go look at Oracle user conferences, find some emails, and actually send them a phishing attack. So I'm sending a very specialized email message and trying to get you to click a link or something. Or an example is I've got an employee and I can actually send a message to my manager that has a URL and I have them click on it and I can get them to do things that they normally wouldn't want to do. Or here's an attack that we've actually demonstrated out using iRecruitment. Parts of this work, this is more of a made-up example, but this is how a classic cross-site scripting would work, is that the attacker is basically entering some malicious JavaScript into a Java application description. And the Oracle will now block this. Several years ago, Oracle wouldn't have blocked this attack, but as part of standard functionality, this should be blocked. And so as part of the application description, job description, so when you're applying for a job, there's a description field, you add some additional comments, someone could actually put JavaScript in there. So JavaScript executes within the browser. So then when the manager brings up that web page and actually looks at that description, that JavaScript would execute in the browser. As part of that JavaScript, it's actually calling a hidden frame and is actually executing some Oracle Business Suite functionality. As an example, you could actually immediately approve that job description or that job application, therefore the person would be hired, and do things like that. And this is kind of a made-up example, but this is the type of attack against Oracle Business Suite that someone would undertake and can be effective. Mostly when we demonstrate this in real life to clients, we actually change passwords and things like that. That's kind of the most effective attack that we've found, that I could go in and just send a URL to someone and change that person's password if they're already logged into the application. The major problem with cross-site scripting is that there's a billion different ways to do it. So these are just examples of what cross-site scripting attacks would look like. So fundamentally, all you're trying to do is execute a script within the browser of the client. So the person you're sending the email to or trying to redirect them to a website, you include some JavaScript and it actually does something in their browser. And since they have a session in Oracle Business Suite already, it'll do what they want. It'll do what you want them to do, and they wouldn't really know any different. But the problem is there's so many different ways you can do it. It's very difficult to go through and actually fix all these different possibilities. So for those of you who want to really know about the cross-site scripting, here's actually a couple of references. So the XXS cheat sheet is actually a great reference. If you go through there and actually look through all the different possibilities of cross-site scripting, because HTML is a very powerful language, you can do a lot with it. It's very easy to do different things in JavaScript, and since JavaScript and HTML are so powerful, you can actually pass in lots of different ways to execute JavaScript. And there's also VB script, and there's all different things you can do. And these kind of websites here will kind of give you an idea if you really want more information on cross-site scripting. So the question is then, how do you actually block these type of attacks? When you've got a lot of unknown attacks coming in against an application, what can you do to prevent them? The key is really all user input needs to be validated. You need to look at the end user input. So basically anything coming from the client should be untrusted. And Oracle Business Suite actually does a pretty good job of this. So it actually has some built-in filters. So they do actually have a cross-site scripting filter. So if you actually go in and type in, we'll go back, that first example at the top here, if you just go type that into any description field or any major field, just go to the login page and type in script alert 0/script. The Oracle Business Suite will actually block that. So there are some basic filters within the Oracle Business Suite. Unfortunately, the way the filters work is, as XSS is so powerful and there's so many different ways to do it, the filters are really just trying to keep up. And we found several issues, easy ways to bypass the filters. So unfortunately, the filters don't work that well. They're a great starting point, so if there's someone just kind of doing some basic things, you can actually block them pretty well. The second way to do it is using a web application firewall. So now you're actually looking at putting another layer in front of the application to try to block cross-site scripting, SQL injection, and other attacks. Unfortunately, those type of filters and ways to look at cross-site scripting, SQL injection, it's fairly CPU intensive. You have to parse every input. You have to spend a lot of time doing it. And web application firewalls are designed for a large swath of applications. They don't want to add much overhead into the application. And since they're a single appliance typically, it's hard to check every single parameter. So they work fairly well. They can detect most. But typically they work on static signatures and things. A third way you can do it is actually add another layer And this is running as part of the application. So AppDefend is actually running as part of the Java stack of Oracle E-Business Suite. And one of the advantages of running there is you can much more intelligently check all the parameters and user input. And AppDefend actually uses one of the OWASP libraries called Anti-SAMI, which is also delivered with Oracle E-Business Suite, but they only check a few parameters. AppDefend checks every single parameter and uses some intelligence, knowing if it's got end user input, if it's possibly long enough to actually contain an attack, and things like that. And what, as an example for the cross-site scripting check, Anti-SAMI is actually rebuilding the input to see if it actually is a valid HTML or JavaScript piece. So it's checking all the different combinations and possibilities to see if it's actually code versus user input, which is different than a signature. If you're the Oracle E-Business Suite filter is just checking, well, is it a script tag? Is it these type of tags? Well, a different way to do it is you actually check to see if it's actually code versus anything else. And so this is, again, another layer that you're adding into the application to hopefully block all these unknown attacks. So anything that's coming in that looks like an attack would be blocked, and you're trying to eliminate as many false positives as possible. So this is, again, an example of just adding another layer into the application to prevent things that you don't know about. And this is kind of where you may get attacked, and you have to at least be aware and have additional layers of protection that aren't provided in the application natively. So that's two examples of areas where kind of with security vulnerabilities that potentially can be attacked, can compromise the application. Again, because the application is running apps, SQL injection is very powerful and trying to block those type of vulnerabilities. So we'll now look at a totally different area within the application, encryption. Some organizations kind of get this and some don't. So basically what we're talking about is encrypting the traffic that's flowing between the client's browser and the application server. And what a lot of people don't understand is the traffic that's flowing across the internet is unencrypted. So what I did here was actually put a sniffer on the Oracle E-Business Suite. So I had a browser out running on my laptop, and I connected the Oracle E-Business Suite environment and went to the login page and signed in as the sysadmin user. And the fields in red there are basically sysadmin, and my password is the password that we kind of set up for sysadmin. Not a very good password, but just as an example here so you can see it. That's flowing across the internet unencrypted. So any point that information is being accessed covertly, maliciously, or even on your desktop, if you've got a Trojan or something like that, that is basically inspecting incoming and outgoing traffic, which is actually not common for a Trojan to be doing, but that's actually some keystroke loggers and things like that do that. You can actually fairly readily capture what's being passed back and forth. So if you're doing credit card numbers, social security numbers across the internet, all that information is going unencrypted. And this also applies internally. So a lot of organizations haven't deployed SSL or encryption across the internet for their Oracle E-Business Suite environment. And basically the risk is that someone can see that traffic and potentially capture it, manipulate it, things like that. And that's why you want to do encryption, is to kind of protect against this potential vulnerability. So the way you encrypt it is use SSL. So anyone who's ever typed into the web browser HTTP versus HTTPS. So when you type in HTTPS, basically you're telling your browser to use SSL encryption. And so the application server has to be enabled with SSL. And so Oracle's got a couple notes, and they fully support SSL. So you basically just use my Oracle support notes and basically enable SSL. Unfortunately, SSL is kind of difficult to implement because it does require certificates, and you actually have to create a certificate request, get that information back, configure it in, and things like that. So it's not the easiest implementation. It's very doable, but it does take a number of steps. One note, if you are using Oracle's native SSL on the application server, you do have to disable some of the older ciphers. There's been some issues which aren't really that critical. It'd be fairly difficult to hack an Oracle E-Business Suite environment by breaking the SSL encryption via some of the weak ciphers, but it is very doable. But it would probably be not worth someone's effort. They probably move on very quickly. But it's best to disable SSL v2 and weak ciphers. And one of the appendices, it actually gives you detailed instructions on how to do that. The other option is actually using SSL encryption acceleration on the load balancer. So if you're running any sort of load balancer, this would be an example would be F5's Big IT. You can actually set up SSL encryption on that, and you offload the effort and the processing from the application server to the load balancer, which have optimized hardware, can spend a lot of their CPU cycles doing that versus doing those CPU cycles on the application server. Most of our customers use some sort of load balancing device, and you can actually very quickly get that up and going. Then the other advantage is all the SSL certificates for all your web applications are in one point. So for the Oracle eBusiness Suite, if you're going to do it on the application server, here's the Oracle MetaLink or my Oracle support notes for enabling SSL. So you kind of just follow the steps within the middle tier. There's a second part of both these documents that actually talk about encrypting between the application server and the database. Since that traffic's typically in the data center, we don't see a lot of risk there for someone hacking into your data center, putting a device on and actually capturing traffic there. Plus, it requires Oracle Advanced Security, which is actually a fairly expensive option. But between the client and the Oracle application server is much more critical because that's going across the internet, much more vulnerable, so that's really where you need to implement the SSL encryption. So that's kind of three different areas, that you need to be thinking about that are potential risk points within the Oracle eBusiness Suite when deploying it to the internet. And so kind of the main focus is trying to add in a layer of security. And one of the areas we talked about here was adding a web application firewall. And so web application firewalls are really just specialized firewalls that look at web application traffic. And so they're trying to block attacks by just looking at the web requests going back and forth between the client and the application server and trying to detect things like SQL injection, cross-site scripting, known security vulnerabilities. All the major web application firewall vendors include a long list and frequently updated list of web application security vulnerabilities. Unfortunately, they very seldom include those for the Oracle eBusiness Suite. They just don't have the research teams that understand Oracle eBusiness Suite. So they do promote that, oh yeah, we can block every known vulnerability. Often they don't do that for Oracle eBusiness Suite. They're often implemented as an appliance. That's very critical. They're dedicated hardware. They work very well. They're optimized for what they're trying to do. And then it's actually a requirement for PCI compliance. So if you are running credit cards in your Oracle eBusiness Suite environment, one of the requirements is to implement a web application firewall or do periodic security reviews. So it's actually probably cheaper and easier to do a web application firewall, and that's why most people satisfy the requirement by implementing a web application firewall. So it's very key is if you do anything with credit card numbers, and the one exception there is for your corporate credit card numbers, but if you're doing any customer credit card numbers, supplier credit card numbers, or anything like that, your environment needs to be PCI compliant, and one of the requirements of PCI compliance is a web application firewall fundamentally. So for web application firewalls, there's a number of options. One of the simplest way, and documented as part of the Oracle DMZ notes, is actually doing a reverse proxy server. And you can actually put in mod security. And mod security is an open source option, works very well, it's fairly effective. And one of the advantages today with mod security is in the last couple of years, OWASP has actually come up with a large set of rules that can be actually implemented out of the box with mod security. And these are actually pretty good rules. Unfortunately, they do require a bunch of tweaking for the Oracle eBusiness Suite. They do detect a large number of false positives. So you do have to run it for a couple months and try to tweak them and eliminate a lot of the, probably about 10% of the rules have to be turned off for Oracle eBusiness Suite. But it is actually a fairly effective solution. If you run Apache 2.0, you run mod security, it works fairly well, especially for a smaller implementation, lower cost. You just need the hardware. The software is all free. Another option is if you're running a load balancer like F5, NetScaler. Most of the main load balancing vendors actually provide a web application firewall built in. F5 actually has a pretty well regarded product. So if you're running that, you can actually just buy the license for Web Application Firewall and run the load balancer with the Web Application Firewall inside. Also, you can do SSL termination at that point. It's a very effective, easy to implement solution. You can do it for all your web applications. Another option is using a Web Application Firewall that's a standalone dedicated appliance. There's vendors like Imperva who deliver a very nice Web Application Firewall, and so you buy their appliance and basically hook it up inline. So instead of going directly from the internet to the application server, you end up going through the Web Application Firewall. And again, it has predefined rules that can block SQL injection, cross-site scripting fairly well. And then a final option is AppDefend. Integrigy makes AppDefend, and basically what we did was develop this about 7 years ago when we just really noticed that there was a number of issues within the Oracle Business Suite security, and our customers were asking us how to protect against some of these known vulnerabilities, how to limit the scope of the application running on the internet. And so we actually developed our own Web Application Firewall that's only for the Oracle Business Suite. One of the advantages of AppDefend is it runs within the Java technology stack, so it can see things that other Web Application Firewalls can't. So some of the problems, though, with Web Application Firewalls is they're really not meant for Oracle Business Suite out of the box. Most of the Web Application Firewalls do have to be tuned for your applications, and that can be a fairly lengthy process. Oracle Business Suite is pretty consistent about what it does, but it does it a little bit differently than most applications, where Web Application Firewalls are looking at a lot of PHP applications, email applications, things that hundreds of thousands of customers are running versus maybe 1,000 of their customers are running for Oracle Business Suite. So they don't do a very good job at providing out-of-the-box rules, things that are well-tuned. You do have to go through the kind of the learning process, and it sees what normal traffic is, but then as soon as you turn on a new module, all those rules get thrown out, and you actually have to start over and redo it for that new module. One of the hard parts is unless you turn on the URL firewall and do a good job there, they can't block the unused Oracle Business Suite modules. That's kind of one of the main security risks we see with the Oracle Business Suite is you really want to disable as many modules as possible and reduce your risk exposure on the internet. And then finally, unless you've got a Web Application Firewall in place today with a team, it's actually a fairly costly effort just to do it for Oracle Business Suite. You probably have more than one web application, but if you just have a couple, you haven't really put in a Web Application Firewall, it is costly. It can be $100,000, and you can probably spend $50,000 or $60,000 in consulting. So it's actually a fairly steep learning curve, steep cost to get it implemented initially. So we've actually developed AppDefend for Release 12. We've also got a limited version for 11i. But for our Release 12 version, we're actually running as part of the Java technology stack. We work as a servlet filter, and we're actually looking at all the requests flowing back and forth. And also we can see error codes. We can see who's logged into the application. We can actually do queries against the application database to get additional information. So we're just doing a lot more in terms of detecting attacks. And fortunately, we know the Oracle Business Suite very well, so we actually designed it just for the Oracle Business Suite. We can also do application logging within AppDefend. One of the things for PCI DSS compliance, so if you're running any credit cards, is you actually have to have a complete log of everyone who's signed into the application. Well, AppDefend can actually do that for you versus it's stored in the table as part of Oracle eBusiness Suite, so you have to come up with some mechanism to go pull that information out, put it into your central logging solution like ArcSight. Well, AppDefend is already configured out of the box to do all that for you and has about 10 different logging solutions all defined and can send that information immediately along with alerts about attacks and things like that. Another area where AppDefend is specialized is we can actually limit the Oracle Business Suite modules you have. We're doing more than the URL firewall because we actually have a lot of logic built into AppDefend to actually detect exactly what module it is, break it out. Even within OA framework, we can actually detect the modules based on the different pages and functions being accessed. And then finally, there's an area that we see a lot of customers doing now is actually deploying web services to the internet. So you've got some suppliers or something, and you actually just want to open up potentially a SOA-type web service to the internet. This is becoming much more common, and you actually have to have some sort of layer of protection in there to either limit access, prevent some form of XML injection, and there's a number of specific XML type of attacks. So AppDefend can also do that for you. So these are kind of just some layers of protection to try to add into the application to provide additional protection. So that was kind of a brief overview of some of the major issues. Again, this presentation came from a general presentation. We were talking about web application security, and people said, okay, what else can we do? What other layers of protection can we add? And we kind of picked out some of the key areas that you need to be thinking about and some of the risks. So here's kind of my contact information. Integrigy is always open to questions. We always want to get feedback from Oracle customers about what they're running, what are some of the things that they're looking at, where they're trying to struggle with security issues. So we're always open. We have a blog that we actually publish out a lot of Oracle security information. Most of our knowledge is actually published on our website in form of white papers and blog posts to provide as much information to people as possible on web application security. So actually, I'll turn it back to Phil, and we can open up to some questions.
Thank you, Steve. We've got several questions here have been submitted. I think the first one, our developer team would like to expose some web services to external partners. What security issues are there?
The web services we don't think have actually been vetted as much by the Oracle security team and customers in general. So it's kind of one of the newer parts of the Oracle E-Business Suite, and there's a lot of functionality there that people don't understand very well. And most often what happens is it's just opened wide open. It's just like, oh, we need to enable this. They kind of just publish some services out, and they're off and running, not without thinking about it. So you do need to spend a little bit more time going through, especially the native Oracle E-Business Suite web services versus deploying a whole separate SOA infrastructure. So you do need to spend some more time looking at exactly what's getting deployed out, making sure the security is set up correctly.
Okay. Next one. Do you know if a product like Microsoft's Threat Management Gateway, or TMG 2010, is an adequate web application firewall?
TMG is actually a fairly decent product. We actually run it internally because we actually have a customer case where we actually did a lot of testing out for them. So we actually have a test environment of that running. The one area it doesn't provide is a pre-defined set of rules. You can definitely define your own rules, but it's not delivered with the strongest set as compared to a product like Imperva, which delivers a very good rule set. They have a whole research team that's doing it. Microsoft tends to fall behind in that regard. So in terms of just providing some basic functionality, it's definitely there. You can add in a lot of your own rules, but to kind of be leading edge, having a well-defined set of rules that also can learn the application, that's kind of where it falls down. But it is a strong product. It's just kind of what's out of the box and what's already configured. If you spend some time configuring it appropriately, it's definitely can be a decent product.
Okay. Next one. Management wants external access to self-service HR for 100,000 employees, but IT security is pushing back. Is this a good idea?
We've actually gone through, we've got 2 customers that actually have deployed a similar kind of configuration. So basically the scenario is you have a lot of different employees, especially in a retail environment or something where you've got a large number of kind of minimum wage people who are out at locations who would be mostly accessing it from home. So Oracle provides a lot of the functionality so they can just check benefits, check out their paycheck, maybe change their address. We've actually found a number of security issues with the core functionality there, especially on the registration side. So you are opening it up, but you do have to be very careful about how you handle the self-registration piece. Make sure you do a security review of that because we have found issues in that. Like today, we do a number of penetrations like on the iSupplier module. We don't find any security issues there anymore. But I can tell you multiple cases where recently we found issues within the HR self-service, especially when there's any customizations there. That's a big issue because now you've got your own developers or maybe an outside consulting firm doing some development there, And it's easy to get that wrong because the way, if you think through a self-registration process and all the steps, you have to kind of answer some questions. You have to put in maybe your social security number, different questions. It's easy to screw that up. And we found a number of issues there. Especially in a lot of retail organizations have younger people doing this. So one customer, we were told that basically their average age is about 20 for someone who would be registering. So probably computer savvy. If they get terminated or something, they would have a grudge against your organization. They know how the application works. That's a great threat. If you kind of look through a threat matrix, that's a big one. Somebody who's got a grudge, has some computer savvy, would want to hack you. That's how you'll get attacked. And then especially because the application is vulnerable. If you do penetrate the fairly light layers, it's running as apps. So once I can pull back any data, I can get full access to the application because it's running as the apps account. So you do have to be diligent. You have to be looking at some extra layers of protection. And I would strongly recommend doing any sort of code review on any custom code you're doing, and potentially a penetration test if you're a large environment and can afford that kind of resource.
You mentioned iSupplier. The next question, what will keep you up at night deploying iSupplier?
So kind of as we talk through this presentation today, the thing that always keeps me up at night is if once someone gets through, you're running as the app. So they can bring back any data that they want. So potentially, if I'm running iSupplier and I've got HR, you always have to think about it as you're running your HR system on the internet. That's fundamentally what you're doing. You may not be able to just directly access it, but once someone can get through, they can access that data. So anytime you open it up to the internet, it doesn't matter what module, you've got that risk. So it's a very diligent step-by-step process and making sure it's secure and spending the time. Kind of the thing that keeps me up at night and what we look at for our clients is things change over time. I can't tell you how many times we've gone in day one, did a security assessment, found 4 or 5 things that weren't quite set correctly. We kind of cleaned it all up. Then we go back 6 months later and, oh, by the way, they did something stupid and they've opened some vulnerability or some hole up. URL Firewall is one that gets turned off all the time by accident. Maybe 25, 30% of the time, you'll go back 6 months later and the URL Firewall is all of a sudden turned off, and now you've opened up your exposure. So the application is a big, complex application. Unless you're diligent and looking all the time, things happen. Things change. Somebody goes in and has a production problem. They turn on the diagnostics, and basically about this page shows up. And so if you ever look on your external deployment, you see it down in the lower left-hand corner. It says about this page. There's a lot of diagnostics information behind that. It tells you a lot of information about the application, what's running, what versions are running, those type of things, and that can provide an attacker information. That gets turned on all the time because, well, someone's having a production problem, the DBA goes and turns it on for a few minutes just to try to diagnose it, and of course, what do? They forget to turn it off, and it sits there on for 6 months. I can't tell you how many times that happens. So the thing that keeps me up at night is, especially after we've done an assessment, is, okay, what happened tomorrow? What happened the day after that would kind of reduce that everything was set up perfectly? That's kind of one of the bigger problems. Once you've got it set up right, you can actually protect it fairly well. If you kind of add in some extra layers and kind of lock it down and spend the time and have some patience to get it right, it's a fairly secure application until the next vulnerability comes out that's discovered by somebody. But you've got a window of opportunity, a window to fix that. But it's those things that are changing that would keep me up at night if I owned an Oracle Business Suite environment on the internet. It's kind of just being diligent. You got to spend every single day checking it and making sure it's right, and at least monthly or quarterly doing a little bit of a review and making sure all these settings haven't been changed back.